morning. Can you guys hear me, or the mic is not working? No? So I think we will make it easier. It is my pleasure to introduce Mr. Chaitanya Rudrabhatla. I hope
Rudrabhatla,
I'm spelling your
yeah.
name correctly.
No, you did not butcher it.
I didn't butcher it, that's great. And he's a technology leader and a senior solutions architect with over 15 years of experience in designing, developing, and maintaining enterprise applications. He's currently working as an executive director at Sony Pictures, and he is going to be presenting this talk titled Orchestration of Blue-Green Deployment Model with AWS Deployment, Document DB, and EC Cluster using Terraform. And let me just give a pass it to him. Thank you very much for joining us.
Oh, thank you for the introduction. And thank you everybody for choosing to come to my session. I hope you enjoyed all the keynote speaker sessions earlier. So, as she mentioned, let me go. Yep, sorry. So I'm Chaitanya Rudrabhatla. I work as an executive director, solutions architect at Sony Pictures. Me and my group, we are responsible for handling the external facing marketing and digital content applications at Sony, where our major goal is to have like a scalable infrastructure at Sony. We are responsible for developing the applications as well as deploying. So our customers customer load keeps varying. So one of our major challenges is auto scaling our deployment. So that's what we are going to talk today. Before we jump in, a little about my personal stuff. Like apart from work, I like contributing to the internet blogs and internet communities, and I take pleasure in traveling, particularly to national parks, and I like hiking. So before we talk about the blue-green deployments and the AWS, ECS, and Terraform stuff, I'd like to touch upon some basics of DevOps, how we have. I'll walk you through the journey, like what we have done at Sony in the last couple of years, how we have adopted DevOps, how we have implemented the microservices, how we have gone with Docker, and then finally ended up in AWS, and how we have adopted the infrastructure as code using Terraform. So I think like all of us would have seen this kind of message on the websites many a times in our lifetimes, right? So personally, it happens to me every time I sit on and try to do something critical, like pay the bills on the last day. I get to the site, it happens, like Murphy's Law, right? It has to go wrong. Or sometimes like when you're watching your favorite show on a weekend, this comes up. So it's pretty frustrating, right? So though it's really frustrating, if you check the reality, many times these sites are down 95% of the times for the planned outages, and 5% of the times it could be like unplanned disruptions, right? So these planned outages are good because the technology is rapidly changing, so is the businesses, right? So the businesses keep changing, they keep evolving, so the change is unavoidable. Now, to handle the change, we need to have like newer code and newer softwares to be deployed. And these softwares, while deploying, they cause outages, and the sites go down. So over the period, like in Sony, when we were running in the traditional model, we were like taking huge outages, like maybe an hour outage, or sometimes like half a day outage in case of like bigger patchings and stuff. And we were always like brainstorming solutions, what could work for us. So that's when we found out DevOps. Like it was mentioned in one of the keynote sessions, like agile and DevOps is so overused these days, like it can cause a lot of backlash if I talk more about it. But then, yeah, the DevOps was really a solution which helped us in streamlining our code as well as the deployment models. So as DevOps clearly states, DevOps doesn't need, the change doesn't need to be an outage. So when we were like adopting DevOps in the initial stages, like we were like really not sure what it would do. So I think for the organizations which are in the DevOps structure, they can see like with the DevOps model, you can have 46% more frequent deployments, which means like if you're traditionally deploying once a week, you can deploy 50 times. And you can have like 440 times shorter deployment cycles, which is like from an hour, you can reduce it to less than a minute if you're really using the DevOps efficiently. So this is sourced out of the DevOps report from the Puppet Labs. So what exactly is DevOps, right? Like this keeps like always getting into our heads. Everybody starts using DevOps. Some people think DevOps is like a set of processes, and some people, like when I talk, they think it's set of tools, and some think it's set of technologies. So what exactly is DevOps, right? If you think, after we implemented, what we realized is DevOps is not really tools or technologies or processes, or not these alone, but then DevOps is like a cultural mindset, which is a change in the cultural mindset for the developers and the ops groups. So before adopting this, in our org, we were like having a traditional dev team and an ops team which sit in totally separate locations, and the communication was literally zero. So dev guys develop something and they just hand it over to the ops guys, and they think their work is done. Many a times ops guys have no clue what's happening, and they end up deploying in a wrong place or missing a configuration, and that would have caused so many outages or so many firefightings in the past. So DevOps is nothing. It's using your tools, technologies, and processes, and establishing the digital automation pipelines. Not just that, but also having enough unit and automation test cases right from the time you develop your code to the time you take it to the infrastructure and deploy it, and then even operate it. So it's like a full loop where you have enough set of practices and tools and enough communication between your dev and ops groups to move the code successfully into production and maintain it successfully there. So I know most of us would have already seen this. This is the famous Devops loop. I'm not going to dig deeper in this. It clearly states like developer and ops have to get in touch at every point and do the handoffs in a systematic fashion. Again, like DevOps, as you can see in this bar charts, like DevOps runs from the time you code to the time you operate. It doesn't start or end at any certain step, but it runs through all your dev cycle. So when we started implementing DevOps at Sony, few of the key things which we picked up and which really helped us over the period are CI/CD, of course, like where we have implemented Jenkins, Nexus for our artifact repositories, and implemented the CI/CD. And then later we have realized microsite design patterns are also helpful. We'll get into that a little in the next slide. And then eventually we stepped into the containerization and infrastructure as code. So coming to microservice architecture, what led us to pick up the microservices? So in the recent traditionally we were mainly monolith based applications where everything, all the application modules, all the front end, back end, database code, everything was packed into like one big unit, and the whole unit was like compiled into a WAR file or an ER file, and it was like moving all the way from the developer machine into the production servers. So the problem with that was like the deployable file was too heavy. Sometimes it would range from 300 MB to 500 MB depending on all the libraries what you're putting in your code. Because of which the transfer is slow, the deployment is slow, and on top of it we had all of the challenges. Like if your website was making multiple modules to serve different groups, if you have to update a single page for a single module of a user, you would have to deploy the entire monolith application. So everybody would take a downtime, right? So that was one of the challenges, because we had marketing groups across the globe and their purposes were all different. So there was no need for one group to be hit with an outage when there was an enhancement happening on the other group. So that was one of the primary reasons why we had to pick up microservice architecture. So microservices are nothing but these are the loosely coupled fine-grained mini applications. So think like this: if you have a big application, you break it into like 100 smaller chunks into a meaningful way which serves your business. That is microservice, right? Microservice proved to be very helpful for us because of all the defects which were there in the monolith. Microservice seems to have solved it, because now in place of a huge monolith, you have 100 smaller pieces. So if you have to deploy a new enhancement into one area, you can just deploy the single microservice rather than 99 other pieces, right? So, and since these were lightweight, the time with which we could bring these microservices up was very minimal. So there was like a huge gain just moving into the microservice world itself. As you can see in the picture, though microservice is advantageous, it just is not simple to implement, right? It has too many configurations. Like you have a discovery layer with your service routing, service discovery, and you need to have a constant health check because you have now your application is running into 100 different pieces rather than a single one. You need to make sure all your pieces are running healthy, right? So you need to have health checks. And then you need to have your circuit breakers. Like when something's not running healthy, you need to have a circuit breaker to cut the link off to that service and route the traffic to the healthy one. And apart from this, you also have like orchestration, like because these services run on multiple different processes which yields different ports. So you need to have an orchestration done so that your discovery layer can discover the service what it needs to. So it needs to know the port where your service is running. So that's the orchestration complexity. And containerization and image registry come as a byproduct, because if you're doing microservices, there are reasons to go to containerization methodology. We will get into that in the next slide. So as a whole, microservice, though it was very useful to us, it came up with its own complexity and too many pieces in it. So what we got immediately after we got into the microservices, this was the thing. So developers are always like fancy the new stuff. They jumped onto the Node.js and Spring Boot based microservices. They built all the fancy microservices, hundreds of them all across the company, right? Now they think this is running fine in their local developer machine, and they give it to the ops just like the old school. Ops try to run it, it crashes. So all firefighting, right? So how do we avoid? We were brainstorming continuously, like what do we do to make this better? And that's when we found Docker. So Docker was really a good solution to solve this problem because, you know, with microservices, as I said, there are too many pieces in it. Just like our favorite Spider-Man movie, right? Like with great power comes great responsibility. So it's like packing all the pieces. Like your microservice can have multiple application properties, configuration files, database configuration, libraries. So packing them, which are needed for each microservice, and successfully porting them from your lower environment to your production is a challenge. Docker helps us in that challenge because it helps to wrap all the things which are needed for successfully running your service and taking it all the way from developer machine to your dev, QA, and prod. And there is no surprise element at all because you're shifting the entire container. You're not moving your application deployable itself. So this is a high-level diagram what I put together to show like what is the difference between a VM running in the data center to the Docker container. As you can see, in the data center world, we have the bare metal servers wherein there are host OSs, and then you have a hypervisor layer and which splits into multiple the guest OSs. The problem with this setup is the binaries and libraries for each of your guest OS are so heavy. Now if you have to restart or reboot a VM, it takes a lot of time. On the other hand, if you look at the total corner of the slide, you have the Docker container where on top of hypervisor you have a Docker engine running. So this helps to spin the containers, which are like teeny tiny containers which just have the binaries and libraries which are needed to run your application. So you pack your Docker container with what you need. Since the application needs are limited, we end up choosing lightweight things like Alpine version of a Docker base image and then extend to put our libraries. And that's when we realized like the amount of time which or the Docker container itself becomes like 100 times lighter than an enterprise Linux version if you have picked up the Alpine or any of the lightweight Linux versions. Now, the Docker itself is helpful, right? Because it solved the problem of porting the code from a developer machine into the final production environment. But then again, like Docker still doesn't solve the problem of the orchestration, because when you have multiple microservices running, like I said, you need to orchestrate the ports and the traffic, and you need to check, do the health checks, you need to do the traffic routing, you need to do a service discovery. So this is all an overhead. And particularly if you're running in a data center, maybe you can handle it, like because if you devise your application just to have 5 to 10 microservices, you can manage it maybe. If you're running in like 2 nodes, it ends up having like 10 containers. Somebody can try to manage it. But on the other hand, if you have a bigger application where you have like 50 Docker containers and you scale it to like 5 nodes on the cloud, then you have like 250 containers running on the cloud. So routing the traffic or doing a health check, I don't think it's humanly possible. So that's when we were searching for the softwares which will help us in that. That's where we picked up the Amazon ECS. So ECS is an elastic container service offered by Amazon, which was helpful to us in orchestrating these Docker containers on the cloud. As you can see, the ECS implementation, you can choose your cluster, the servers in your cluster to be either the plain EC2s or the Fargate. Fargate is like the version which is provided by the Amazon, where you don't need to maintain your server. So Fargate is advantageous where you don't get billed based on the servers, but you get billed based on the compute time. So only when your service is being hit, that's when Amazon charges for your usage. As you can see, you can have like multi-node ECS cluster and where you have the tasks running. So if you look in my diagram, there's MS1, MS2, and MS3, which I used it for the services. Picked up 3 services just for easiness here. So each service would actually have a task definition, which tells like what the task is going to be, right? It tells like which Docker container it needs to pick up, what is the CPU your service needs, and what is the memory. All the configuration which is needed for your container to run, that's mentioned in a task definition. And then while the services are being spun up, you get to choose like how many instances of your task definition need to run for your service. For example, if you have a user service and you have like hundreds of thousands of users, you can specify your task definition needs to spin up a minimum of 20 instances and a maximum of 100, but your desirable count is 50. So you can pretty much define what is your minimum, what is your desired capacity, and what is your maximum capacity while spinning up the services. And then there's this component of elastic load balancer, or nowadays it's application load balancer, right? So the ALB is the one which helps us in routing the traffic. So we configure the listeners. So listeners are nothing but the path identifiers. Whenever a request comes from your front end, the listener picks up the path, and then it has a target group which tells for this path the request has to end up in a target group, and the target group is the one which listens on a port. So it routes the request to a certain task running on a certain port. So ALB is the one which does all the service routing, and it also does the health check. So it knows all the containers which are running, and if something's not the heartbeat is not listened within the configured time, then it drains off that service. Let's go back. So now we picked up ECS as one of our orchestration mechanisms. Along with ECS, there are other players in the industry. You have EKS, which is Amazon version, or you can choose the Kubernetes, which is the open source version, or you can pick up Docker Swarm to orchestrate your Docker containers. Depends on your application and your enterprise needs, so you need to make a decision which would suit your design better. So in our case, we picked up ECS as a solution to orchestrate our containers, right? Now the immediate next problem what we had is doing through the console or a system administrator doing it was fine for a POC level, right? But then if we had to make it more repeatable process, or not make it dependent on one single ops person, but have it like a more organized fashion, we need to have code. So that's when we ventured into the infrastructure as code area. Like mentioned here, the IAC really helps us to make the process repeatable, and it's more scalable. Like if you have to spin up a total new ECS cluster, or you want to spin up your entire AWS infrastructure, if it's written as a code, it is very convenient. You can clone it in like a matter of minutes, right? Leaving the databases. So what were the options for IAC? We looked into multiple. We were already on Ansible and Chef within the organization, but then we found for the AWS, Terraform as one of the HashiCorp's Terraform as one of the softwares which is more convenient. Couple of reasons, right? Terraform is more a declarative programming rather than super strict syntaxes, so it's easy for both the developers and the ops guys to pick up and code. And then this is one of the advantages of Terraform is it captures the state. When I mean the state, what I mean by it is if you write a little script to say Terraform spin up 5 EC2s for me, right? Terraform captures the state. Now you go and change the script. Rather than 5, you make it 7. It wouldn't spin up like 7 more EC2s, but rather it checks its state and sees like there are 5 already running. So let me just run 2 more for you, right? So Terraform state is one of the biggest advantages, what you don't have in Chef and Puppet. But again, like these are configuration management tools, and Terraform is more of an orchestration tool. So you can build up the infrastructure, but in order to do the configuration management, you need to pair up your Terraform with either Chef or Salt or something like that. CloudFormation, what I put here, is also pretty good with AWS, but the thing is, you get like vendor locked if you want to move into a different cloud, Azure sometime later. Terraform would be more vendor agnostic, so it's better to be on Terraform. Now, since we talked about our journey where we ended up with ECS, with Docker, and with Terraform, the next thing what we wanted to look into was the blue-green deployments. Pretty much, blue-green deployments it's no new concept, right? It's existing. It could be even done in the older data center days, wherein you can clone the entire infrastructure, have like a parallel environment running. On the parallel environment, you can deploy the newer version, and then the older infrastructure could have the older version. But the biggest problem there is data center, your resources are limited, it's not cost effective, and it is too much of effort to make a parallel clone of your infrastructure, right? So that's when we picked up the cloud and all these steps. So this gives like a high-level visualization of what blue-green deployment does. If you have the blue version, which is your version 1 of your application, in the diagram, the DNS is routing to the older version, and then you have the green version. So you parallelly spin up a brand new infrastructure, deploy your new version of the code. That's your green version. Now you can have your DNS route to the green version while the blue is up and running. So the advantage with this is your customers would see zero downtime or near zero downtime. So that's with the blue-green deployment. So one of the other important deployment techniques along with blue-green is canary. Canary is nothing, again, it's a sort of blue-green deployment, but then here the deployment is done gradually. Not the deployment, but if you look in the previous diagram, you see the traffic switching from the blue to green all in one shot, right? In canary deployments, you don't let the traffic route all in one shot, but rather you let the traffic route in a phased manner. So maybe you can have, like in the scenario what I told earlier, if you have 100 sets of user groups, maybe you can release a new feature and have one group pilot it by routing the traffic only to that group, and the remaining 99 still be on the blue version of your application. So having understood like what blue-green techniques do, we try to look into various techniques with which we can do blue-green, since we have picked up ECS. One of the things which came into our mind, because we were coming out of the data center world, one of the things which easily came into our mind was swapping the DNS, right? So now with all the infrastructure as code, it is so easy to spin a parallel version of the ECS cluster, parallel version of your load balancer, deploy your newer service, like you can see in the diagram. The blue one is the older infrastructure, green is the new one, right? And then route the traffic from DNS. So you can even do a weighted DNS where you can do like a phased approach. But one of the problems with this is it is not cost effective because you're replicating the entire infrastructure, right? And the second, one of the bigger problems with these is the rollback, because the DNS has its own issues, the TTL, the time to live on the DNS, the cache. It takes certain time to roll back to the older version. So it was like good in some ways because the canary version of the deployment is easy, the complexity is less because you're pretty much replicating the infrastructure. But the problem is you have the cost and the DNS. The other thing what we thought about is the swapping the ECS services, which means right now you have the blue version of the service, suppose say. What you can do is you can parallelly create a new service on the same infrastructure That's the green version of your service. So you have both the blue version and the green version running on the same ECS cluster, and have load balancer do the logic here right now rather than the DNS, right? So the load balancer would have like a newer listener, a newer target group, and a newer service. So the problem with this approach is you need to have multiple listeners, because you need to have a listener to support version 1 and a listener to support version 2. It's a little complex because people need to change in their web applications or their consuming applications. They need to update the endpoints. And other challenge was you need to actually scale down your blue version using your rules, which because it would not drain by itself. AWS doesn't drain it because there is a live traffic hitting it. So the third version, this is what we are practicing right now, and it is proving very effective, is let the ECS take care of doing the blue-green deployments for you. In this, it is similar to what we have seen earlier, but here if you notice, the blue and the green are same services. The microservice 2 is same, which means what we have done is we did not spin up a new listener, a new target group. All we have done here is just updated the task definition with newer version of the Docker container. So what AWS would do is it would pick up the newer version of your task definition, spin up the containers, and eventually it will drain off your old version of your services. So you don't need to manually scale down your older version of the services. So that's the advantage over the previous one. And it is less complex. I mean, it is the least complex, I'd say, because you're changing nothing here. Just you're updating the task definition. So this is what I'm going to run a quick demo shortly to show like what happens. And after we did this, AWS introduced a new style of blue-green called code deploy. It's something in the lines of what we have discussed earlier. Here the listener would be the same, but then there will be you'll initially make two versions of your target groups. Like you'll make a blue rule and a green rule, and you keep your blue target group and green target group. So if there is a new version, your listener would route to the green target group. So with that, we were able to deploy the newer versions of the applications. But one of the challenges is when you do a blue-green deployment, how do you, if your application is running in conjunction with the database? So whenever you are enhancing your application, you need to make equivalent changes in your data structure, right? So there are two techniques. I mean, if it is like not a complex deployment, then you can have your database in such a way that it is compatible with both the old version and the new version. So you can have both your blue and green version subscribing to your data structure. Or the other way is like you can make your both versions compatible with the older version of the database. And if your data requirements become complex, then there are more complex mechanisms wherein you can spin up similarly a blue version of your database and a green version of your database, and then have like a central aggregator pattern wherein the blue traffic would come and the aggregator would route to the blue database. The green traffic would come and route to the green version of the database. So that's about the slides. Maybe I'll run a quick demo which can show the ECS deployment. How is it, guys, so far? Like, I'm rushing through so many things quickly, or? Good. Thanks. So I've created a simple Spring Boot microservice here. All it does is How are we doing on the time? Am I
We are doing good.
doing?
So if you want to run the demo, that's also fine.
Sure. It wouldn't take longer. So if you look, I've written a simple Spring Boot service here with one health check controller, and it has a simple get method, which is info, which would give whatever we are supplying from the web service, right? So all I put here is hello DataCon guest, good morning, right? And what I've done, here is I've put an Angular application, Angular 6 application. All it would do is it would just call the service, take the message, and demo it, display it. So right now this is making a live call to the service, and it is getting the message from the service and displaying in the UI. This is the info service. The response comes as good morning, right? Now, what we can, let me quickly show you the ECS cluster, right? So if you see, there are 3 tasks running in this ECS cluster. What I've done is I've put this in the form of the Terraform code. Maybe what I'll do here is I'll quickly change the message from good morning to good afternoon. Let me do a quick build. So what we are doing here is we are building a newer version thing. I mean, this is the simplest of your update, but in your website, when you have a newer version, you spin up your newer version of your Docker container. So I made a little change. I'm spinning up a green version of the container, right? So build successful. If I go, okay, let me change the Docker version number. So in here, if you look at the task definition, you'd see the task version was 1.2.7. That was the older version of the service. What we have done here is we have spun up a newer version, 1.2.8. Let me go change my Terraform to pick up 1.2.8. So since I spun up a newer Docker version, I just updated my Terraform. The ECS cluster picks up the Docker image based on the variable what we give here, right? So I just updated it to the next version, right? Terraform. All I changed is the Docker version. Like for open source sake here, you could push your Docker, the service which is built, into the ECR repo or the public Docker hub, right, or your corporate Docker hub. So I used the public Docker hub. I pushed the image, the newer image, and I incremented the newer image's version from 1.2.7 to 1.2.8, right? After we do this, we need to tell our Terraform so that our ECS cluster picks up the next version, right, for the blue-green deployment. So I just upgrade the number in the Terraform script. I did a Terraform plan, which tells me like what are the changes. Like I said, Terraform maintains a state, so it knows from the previous configuration, it knows that one new thing it has to add, one to change, and one to destroy, which means the older task, which was there with an older version of the Docker, that needs to be destroyed. The newer task with newer version of the Docker needs to be picked up. That is a new one. And then the target group needs to know to point to the newer version. That's a change. So it would all happen behind the screens. Let me do a Terraform.
Destroys them. When something new comes in, it goes to the new Docker instance. What tells it
So what happens is, since the ALB is smart enough to understand that the new version has come up, what it would do is it would wait for the next green version to come up, right? If you have specified your desirable count is 3, like in my case, so it will wait for the newer version, like 3 new containers to come up. Till then, it will keep running the older version. So users will still see the older message. Like if you see here, the message is still good afternoon, sorry, good morning. So when 3 new containers with good afternoon come up, that's when ALB thinks, okay, I got the desirable count with the newer version. So let me drain the older versions and route the traffic to the new one, right? So that's what would happen when we apply and just ask for a confirmation. Okay, looks like it's confirmed. So let's go back to our ECS cluster. Now if you look at the task definition, the previous one was 1.2.7. Now the new task definition would update to 1.2.8. ECS already picked up. Now if you look at the containers, like the 3 running tasks are there and 3 pending are there, which means your service has 6 tasks instead of 3 now. So if you look, the inactive ones are the old ones and the active ones are the new ones. While it is deploying the new containers, it still shows your old one. So customers wouldn't see any downtime. It would still keep running. And suddenly when all the 3 new things have come up successfully, that's when, and the health checks pass, that's when it changes to good afternoon. So if you have seen, there was no downtime, but we could successfully push the newer version into production. Cool. Thank you, guys. Any questions?
I think we are out of time, but if they find you, I think they will be more
Yeah,
than happy to.
I have my email address
questions.
listed, so please feel free to